Hello everyone. In this video, we are going to simplify exponential expression involving negative exponents, and this is the first part. Please remember that if we are given b raised to the power negative k, we can actually change this negative exponent k to a positive by putting numerator of 1 on top of the b raised to the power k. And so this becomes already positive. Now let's take these examples that we have right here. So if we are given x to the power negative 4, again, we are supposed to rewrite this without negative exponents. So what we can do is that we can go ahead and say we put a numerator of 1 and then we go ahead and write x to the power 4. So this is the expression that is equivalent to this expression that we have right here. So as you can see in the answer that we have here, we don't have anymore a negative exponent. Now what happens if it was on the denominator? So we get 1 over x to the negative 7. In order that we can do that, we are going to bring this x to the negative 7 up and it becomes a positive x to the 7th. So pretty much this becomes x to the power positive 7. So what we did was we just bring this up there and multiply that with a 1, and so we get x to the 7th. Now let's take some more examples here. So suppose we are given a raised to the power 3 over a raised to the power 7, and we're supposed to rewrite this without negative exponents. So I'm going to show you two methods on how we can do that. For method 1, we're supposed to expand this. So a to the third means that there are 3 a's. So I can go ahead and write a, and that is over a to the 7th means there are 7 a's. 1, 2, 3, 4, 5, 6, 7. Now, what are we going to do is we pair them up. So these two will get paired up and they're going to get crossed out. So nothing is left on top, but we remember that there is an invisible 1 in front of the a here. So 1 was left, and so we can go ahead and say that this is actually 1 over a to the power 4 because there are 4 a's. Now we're going to use method 2. For method 2, we are going to subtract their exponents. So this becomes a raised to the power 3 minus 7. So that would be 3 minus 7. So whatever is the exponent on top, we subtract it with the exponent at the bottom. So that's how I got a raised to the power 3 minus 7. So 3 minus 7 is negative 4. So I can go ahead and rewrite this as a raised to the power negative 4. Now we remember that we want a positive exponent. We need to get rid of the negative exponent. So if we want to make this positive, we go ahead and write 1 over a raised to the power 4. So this is the simplified version of this exponential expression that we have right there. Notice that both methods give the same answer, which means that you can use any method. It doesn't matter. Now let's move on to the second one right here. Again, I'm going to set up the two methods here. Okay, so for method 1, I'm going to write down 2 b's on top. So that's 1 and 2, and that is over. I'm going to write 5 b's at the bottom. That's 1, 2, 3, 4, and 5. So there's 5 b's. And so I'm going to cross them out. So these two gets paired up. Again, nothing is left on top. But then again, there's an invisible 1 right there so that we can go ahead and write this as 1 over b to the third power. And so this is the simplified version of this expression that we have here using method 1. And we do the same thing for method 2. I'm going to write their common base, which is b, and I'm going to subtract the top and then the bottom exponent. So that would be 2 minus 5. So this becomes b raised to the power negative 3 because you have 2 minus 5 is negative 3. So then we want a positive exponent. So we can go ahead and write this as 1 over b to the third power. So again, both methods give the same answer, which means that you can use any of the methods. It doesn't matter. Okay, let's move on to the next example right here. So we are given x to the fifth times x to the negative 2. Now there are again two steps that we can use in order that we can simplify this. I'm going to set up this two steps right here. Okay, for the first method, we can go ahead and get rid of the negative exponents here. So we can go ahead and rewrite this as x to the fifth times, again, we put 1 on top of this. So that would be 1 over x squared. So that we can go ahead and multiply these two. So that would be x to the fifth times 1 is just x to the fifth, and that is over x squared. So that we can go ahead and expand this. So we're going to have 5 x's on top. 1, 2, 3, 4, 5. And we're going to have 2 x's at the bottom. And so we pair them up. We can cross them out. So we cross these two. So then we are left with x to the power 1, 2, 3. So this is the simplified version of this expression that we have up there. Now using method 2 here, now we are going to use the same thing. We're going to set this up here. So that is x to the fifth times, again, that's 1 over x squared, because we want to get rid of the negative exponent there, so that we can go ahead and say that we have x raised to the power 5 minus 2. So that would be 5 minus 2. And so that is x to the third. So we pretty much get the same answer, x to the third power. The other way that we can do that is we can add this exponents right here. We can also show an alternate method for this. So that is actually x to the power 5 plus negative 2. So 5 plus negative 2 is actually x to the third. So it's still pretty much the same thing. So others are going to say, like, why do we have three answers now? They're pretty much the same thing. So what we did in this method right here is that I changed this x to the negative 2 to a positive exponent. That's how it came out to be 1 over x squared. So then we can minus, since this is division, so we can minus them. So 5 minus 2 is 3. Or we can just go ahead and add them up right away. So 5 plus negative 2 is still 3. So it's pretty much the same thing. It doesn't matter which method to use. Now let's have the second problem right here. So let's set up the methods here. Okay, so this y to the negative 7 can be made into a positive y to the 7th by putting 1 on top. So 1 over y to the 7th times y to the 3rd. So this means that we get y to the 3rd over y to the 7th. That means there are 3 y's on top, and then there's going to be 7 y's at the bottom. So that's 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. So we can cross them out. So these 2 gets crossed out, or these 3 gets crossed out. So again, if nothing is left, that's 1, and that is over 1, 2, 3, 4, y to the 4th. So this is the simplified version of this expression that we have right there. Now we can actually use this expression that we have right here to the second method here. So we can go ahead and say that we can have y raised to the power, we subtract, we minus these 2. So that would be 3 minus 7. So that we have 3 minus 7 is negative 4. So y to the negative 4. To make this into a positive y, we can go ahead and say we put 1 on top, and that is y exponent 4. And so we get the same answer for this method right here. Or an alternate method for this is just we can go ahead and add these two together. So that would be y raised to the power negative 7 plus 3. So add these two so that we are left with y raised to the power negative 4, because you have a negative 7 plus 3 is negative 4. And so it's the same thing. That's 1 over y raised to the power 4. So the answer is still the same. Okay, now let's move on to the next example right here. Okay, so for the first method, we're going to write it out. So there are 6 x's. So that would be 1, 2, 3, 4, 5, 6. And there are 3 y's. And that is over. We have 2 x's at the bottom, 1 and 2. And there are 5 y's at the bottom. So that's 1, 2, 3, 4, and 5. So what are we going to do is we cancel them out. So we partner them up and cancel them. So the leftover on top would be 1, 2, 3, 4. So that's going to be 4 x's. So that's x to the 4th over. The leftover at the bottom is 2y. So I can go ahead and write y to the 2nd power. So this is the simplified version of this expression that we have here using method 1. Now let's have method 2. For method 2, we're gonna, since this is division right here, we're gonna subtract their exponents. So we start with x. So x raised to the power 6 minus 2. So that's 6 minus 2. And then I will have the exponent for the y subtracted as well. So that would be 3 minus 5. So again, what I did was I subtracted the exponent. So x 6 minus 2. And then the y, I got 3 minus 5. So 6 minus 2 is 4. So I can have x to the 4th power. Y to the power 3 minus 5 is negative 2. Again, we have a negative here. To make this positive, we put 1 on top of it. So this is x to the 4th. And then that's gonna be 1 over y to the 2nd. And so the exponent now is positive. So this can be simplified as, that's gonna be x to the 4th times 1 is just x to the 4th over y squared. So this is the simplified version of this expression using the second method. As you can see, both methods get the same answer. Now let's have the last one here. So I'll set up the 2 methods here. Okay, so we write it out. So there's gonna be 3 x's on top. That's 1, 2, and 3. And we have 1 y. And then at the bottom, we have 5 x's. So that's 3, 4, and 5. And then there are 4 y's. So what are we going to do is we cross them out. So these two gets partnered up and we cross them out. So the leftover here would be nothing on top. But then again, remember, if nothing is left, there is this invisible 1 in front of the x. So that is 1 over, we have 2 x's, so that's x squared. And then we have 1, 2, 3, so we have 3 y's. So this is the simplified version of this exponential expression that we have up there. So for method 2 here, we're gonna subtract their exponents. So both x's, we're gonna write x here as the common base. We subtract this exponent. So we're gonna have 3 minus 5. So that is 3 minus 5. And then I'm gonna have the y and then subtract their exponent. Now remember that there is an invisible 1 right there. So that is 1 minus 4. So x raised to the power 3 minus 5 is negative 2. And then 1 minus 4, that would be negative 3. Now we're going to make their exponent positive. We can do that by putting 1 on the numerator. So this becomes 1 over x squared times 1 over y cubed. Then we multiply them across. So 1 times 1 is just 1. And then we have x squared and y cubed. So this is the simplified version of this expression that we have up there. Now notice that both methods give the same answer. This means that you can use any method. It doesn't matter. The answer would still be the same. That's it. If you find this video helpful, hit like and subscribe for more math videos. See ya!